Hello, sixth graders. Okay, today we're working on median, which basically means the middle number, but you have to do one important thing first, and that is put your numbers in order from least to greatest or latest or greatest to least in order to find that middle number, okay? So it's not a hard lesson, so we'll just get through it really quick. Okay, so 14.2, median. Lesson objectives, find the median of a set of data and use the median of a set of data to solve problems. All right, here we go. Understand the concept of median. So, Barbara drew 3 number cards from a box and wanted to know the middle value, or median, of these values. The median is a second way to summarize the values in a data set with a single number. First, she arranged the numbers from least to greatest. Okay, so she drew a 5, a 12, and a 16. And she put them in order from least to greatest, and her middle number would be a 12. So that is your median. It is that simple. When a data set has an odd number of values, you can identify the middle value, or median, by inspection. The number of values less than the median equals the number of values greater than the median. Okay, moving on. Then she identified the middle value, 12. So the median of the 3 numbers is 12. Barbara then picked another number. She picked a 19 from the box. She arranged these numbers in order. Again, do not forget to do that. So from least to greatest, here she says 5, 12, 16, and 19. Now her middle values are 12 and 16. So how in the world are we going to find our median if there are 2 numbers here? We've got to find the mean of these 2 numbers, which is 12 plus 16 divided by however numbers would be 2. So 12 plus 16 is 28, and you divide that by 2 to get your average, which would be 14. Okay, so when a data set has an even number of values, identify the 2 middle values. The median is the mean, remember mean from last week, of these 2 middle values. Okay, so the median of the 4 numbers is 14. The number in between 12 and 16 would be 14. Agreed? So far, so good? All right, remember the data must be in order before you look for the middle value or values. The data can be arranged from least to greatest or greatest to least, but they cannot be mixed up out of order. All right, next page, next page. Guided practice. So I want you guys to pause the video and solve this page, and then we will do it together. All right? Hopefully you did what you were supposed to. Guided practice, find the median of each data set. The data set shows the weights of a group of students, right? So are these in order from least to greatest or greatest to least? No, they are not. We need to do so. So the least amount would be 86, and then 97, and then 98, and then 109, and finally 117. Now, from our numbers being from least to greatest, are we able to find that middle number? Why, yes, we are. It is 98 pounds, so your median would be 98, okay? Number 2, the data set shows the volumes of water in fluid ounces in some containers. All right, well, first of all, we need to put our ounces in order from, I'm going to say least to greatest. Okay, so the one that's least would be 8. And then next we would have, I would say this one, 16. And then next we would have 32. And then next would be, what is that, 56? And then next would be 64. Okay, so our middle value would be this one, 32 ounces, which would be that one. How did you do? All right, moving on. So the 2 middle, let's see. Oh, the data set shows the ages of a group of people. We have a 23-year-old, 36, 28, 43, 34, and 29-year-old. Okay, so the 2 middle values are, well, first, before we even do that, we've got to put these in order from least to greatest, right? So I'm going to say that 23 is first, is the least, and then followed by 28, and then 29, and then 34, and then 36, and finally 43. Now, from there, can I say the 2 middle numbers? There's not 1 in the middle because there's not an odd number of numbers. These 2 right here would be our middle numbers. Agreed? What do I do next, guys? I need to add them together. So the two middle values are 29 and 34. And the mean of the two middles are 29 plus 34 divided by 2. Okay, so 29 plus 34 would be 63. And then 63 divided by however many numbers we're looking at, 2. So I'm going to come over here and say 63 divided by 2. Okay, so 2 will go into, let's say 6 3 times, and I get 6, and I subtract, and then I bring down the 3. 2 will go into 3 once without going over, and I have 2, and I subtract, and I get 1 left. I'm going to go ahead and put my decimal there and bring down a 0. 2 will go into 10 5 times, and it all pans out, and my median age would be 31.5. How did you do? All right, let's look at number 4. The data set shows the lengths of the tables that one company produces. All right, well, first I need to put these in order from least to greatest. Agreed? Okay, so here we go. I'm going to start with 78, and then 85, and then 92, 108, 135, 200, 210, and finally 264. So far, so good? Okay, now we can say, can we find a middle number from this side going in? Let's see. It would be these two. So that means, darn it, we've got to find the mean. Okay, so 108 plus 135, and that would be 243. So far, so good. I'm going to take that 243, and I'm going to divide it by however many numbers we're looking at, which is 2. I know that 2 goes into 24 12 times. I'm going to subtract, and I'm going to bring down the 3. 2 will go into 3 1 time, and then I have, I have 2 here, and I subtract, and I get 1. Well, 2 doesn't go into 1, so I'm going to put a decimal here and add a 0 here, and 2 goes into 10 5 times, which gives me 10. And I got 121.5. How did you guys do? So far, so good? All right, let's look at number 5, guys. The data set shows the distances that a group of students ran during an exercise. Okay, this one gets a little trickier because we're looking at fractions now. Ooh, all right, here we go. So the smallest fraction I know would be 1/2. I'm going to put these in order from least to greatest first, remember? So 1/2, and then next would be 5/8, and then followed by 3/4. And after 3/4, we would have 7/8 would be the largest. So far, so good. Now, darn it, we don't have a middle number because there is an even number of numbers. So we're looking at these two. What do I do first? I need to add them together. So I'm going to come over here and say 5/8, let's draw a line there, plus 3/4. Well, I need to change the denominator to this so that I can add these together. Do you guys remember? What can I do to 4 to make it 8? I can multiply it by 2. So I'm going to go ahead and rewrite this out. So 5/8 plus 3 times 2 is 6, and 4 times 2 is 8. So far, so good. Now, I can add these together. 5/8 plus 6/8 is 11/8. So far, so good. Is that our answer? No, it is not. We need to take this and find our mean. So 11/8, I'm going to come back over here maybe where there's more room. 11/8 divided by 2, or divided by 2 over 1. Now you all know I don't like dividing fractions. I'd rather multiply by the reciprocal. So I'm going to say 11/8 times 1/2 would be the reciprocal of 2 over 1, correct? And I have 11/16. How'd you guys do? That would be our median. Our middle number would be 11/16. All right. Next page, next page. Find the median of a data set using a dot plot. Okay, so the dot plot shows the number of children in 7 families living in an apartment complex. Each dot represents one family. How many families do we have? 1, 2, 3, 4, 5, 6, 7 families. To find the median, count the dots to find the middle values. Count to the fourth dot from the left in the dot plot. Notice that the fourth and fifth dots have the same value. So the order of the fourth and fifth dots does not matter. All right, so we're going to try to find our middle value of this dot plot. And there's one thing that you must always remember, or you will get a wrong answer, is when you are doing this, you need to count from the bottom up always. So it would be 1, 2, 3, 4, 5, 6, 7. What is our middle number? 1, 2, 3, 4. It would be this one because there are 3 on this side and 3 on this side. But remember that you're always counting bottom up, okay? Otherwise you will get wrong answers. All right, so there are 7 families altogether. The fourth family is in the middle because there are 3 families to the left and to the right of this family. Are there 3 to the left and 3 to the right? Yes, there are. Okay, so the median number of the children is 2. So far, so good. All right, let's try another one. The dot plot shows the number of hours that 8 children spend on exercise every week. Each dot represents 1 child. Okay, so how many kids do we have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so first find that middle number of hours. There are 8, right? So I know that 1, 2, 3, 4, it's going to be this one and this one because there's an even number. There's no odd number here. So would you say that there are 3 on the left and 3 on the right? These 2 are the middle numbers, right? Okay, so there are 8 children altogether. Divide this into 2 equal groups. There are 4 children in the upper half and 4 children in the lower half. So the 4th and 5th children are in the middle. Would you agree? 4th and 5th children are in the middle? Yes. The 4th child spends 2 hours and the 5th child spends 3 hours on exercise every week. Now, they want us to find the median, guys. So first we have to find the mean of these 2 numbers, agreed? So they took 2 plus 3 and they got 5 and they divided that by 2 and they got 2.5. Now, there is a simpler way. If you have a dot on this side and a dot on that side, you could think to yourself, what's straight in the middle? 2.5. Agreed? Yeah? All right, next page, next page. Uh-oh, guided practice. I want you guys to try this and then come back to me. Just 6 and 7. All right, hopefully you did what you're told. All right, so the dot plot shows the weights of a group of immature white-tailed deer fawn, and each dot represents 1 fawn. How many fawn do we have? 1, 2, 3, 4, 5, 6, 7. There are 7. So the median weight of the fawns is going to be, I would say this one is in the middle. Would you agree? There's 3 on the left and 3 on the right. So how many pounds? 100. A new fawn joins the group and it weighs 101 pounds. So add a dot to a copy of the dot plot above. And so I'm going to go ahead and do that right here. I'm going to add a dot. This one weighed 101 pounds, right? So I'm going to add a dot right there. Does our median change? Well, yes, because now our middle numbers would be this one and this one. So it would be the number right in the center. Would you agree? Or we could say 100 plus 101 equals 201. And then find your median. You've got to take 201, divide it by 2. I know that 2 is going to go into 200 100 times, and I get 200. I'm going to go ahead and say that, put a decimal there and bring a 0 down here. So we'll go into 10, 5. Okay, how did you guys do? You may have done this and said, well, it's 100.5. Does this change the median? So you should have put yes. Now it's 100.5. Agreed? Pounds. All right. Moving on. Here we go. Learn, compare the mean and median of a data set. Mrs. Brown took a survey to find out the number of hours the students in her class spent in the public library in 2 weeks. Each dot represents one student. How many kids were there? 1, 2, 3, 4, 5, 6, 7, 8. So find the mean and median. Well, our mean is going to be all of these numbers added up. So 1 plus 1 plus 2 plus 2 plus 2 and 3 and 15. And then divide it by 8, and they got 3.5 hours. Remember, mean? Okay, so the mean is 3.5 hours. The data set has an outlier. This is our outlier. Why is it our outlier? Because it is way out in right field, all by itself. It is the little black sheep, therefore it is an outlier. This value makes the mean much greater than a typical value of these data. Okay, so there are 8 students altogether. The 4th and 5th students are in the middle. Would you agree? 1, 2, 3, 4. So they're saying this one and then this one are in the middle. There would be 3 on this side and 3 on that side, right? Okay, so each of those 2 students spent 2 hours at the library, so the median is 2. Would you agree? Yep, it sure is. Next page, next page. Okay, here we go. B. Which one of the 2 measures of central tendency, the mean or the median, better describes the data set? Which one better describes the data set? Would it be 3.5 right here, or would it be 2 right here? I would say that the median, which is 2, better describes the data set only because it fits more into, this is kind of out in right field. This is where it's at, right? So I would say that the median better describes the data set. Okay, justify your answer. The mean is 3.5 hours. However, all but 1 student visited the library for fewer than 3.5 hours during the 2 weeks. So the mean does not describe the data set well. The median is 2 hours. It describes the data set better because most of the data values cluster around 2 hours. Remember? I would agree right here. Okay, moving on. I want you guys to pause the video and try this one on your own. Okay, hopefully you did what you were supposed to. Guided practice, complete use of the data in the dot plot. The lowest temperatures in a town are recorded over a few days. The dot plot on the right shows these temperature readings. Each dot represents one temperature reading. So how many readings did they have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what is our mean? How are we going to find that? Do we remember? We need to take all of these numbers and divide them by however many readings there were. So I'm going to say 40, there's our first dot, plus 41, plus 46. There's 2 46s. Agreed? Plus 47, plus 3 48s. So 48 plus 48 plus 48. And what does that equal? Altogether, 364. Now they want the mean, remember? So we take 364 and we are going to divide that by however many readings there were. 1, 2, 3, 4, 5, 6, 7, 8. All right, so 8 will go into 36 4 times. And I have 32. And I subtract, and I have a 4, and I bring down the other 4. And 8 will go into 44 5 times without going over. And 5 times 8 is 40. I have 4 left. Well, I'm going to go, I need to bring down a 0 that's not even existent, so I'm going to put my decimal there. And it will go into 45 more times. And 5 times 8 is 40, and it all pans out. So my mean is 45.5. Agreed? So far, so good? Okay, so now we got the mean done. And isn't it mean that in order to find a mean, you have to add all of these together and divide it by however many there are. Okay, and the median is our middle number. So out of these, there were 8 numbers, right? So I know that the 4th and 5th one is going to be where it's at with our median. All right, so I can either say, well, 46 plus 47 is such and such and divide that by 2. Or I can think to myself, I know what is right in between 46 and 47. What is right in between there, guys? 46.5. How did you do? You got it? So blank of the temperature readings recorded are higher than the mean temperature. Well, wait a second. What's the mean temperature? It's 45.5, so I'm going to draw a line right there. Blank of the temperature readings recorded are higher than the mean temperature. 1, 2, 3, 4, 5, 6. Agreed? So far, so good. And then which of the 2 measures of central tendency, the mean or the median, better describes the data set? Well, this would be our mean. I'm going to go ahead and write that. And our median was 46.5, so it's in this range right here, right? Which one better describes our data set? I would say that this one does. This is where it's at, right in here, because this is kind of out in blank space, right? So I would say that the median better describes our data set, all right? Because that's where a majority of the dots are lying, more so over here than over here, all right? Okay, guys, so now you're going to work on your 14.2 practice worksheet. And if you have any questions whatsoever, don't hesitate to email me. We'll see you later, guys. Bye.